Good day, weather technology students. In this video, we're going to talk about how we can combine surface observations with gridded output to draw contours on them in the context of our case study project. And so in order to do this, what we need to do is we're going to go ahead and first copy or duplicate this notebook that we used to read from that surface data we downloaded from the Iowa State Archive. And then I'm going to go ahead and rename it just so we have it as a unique name here. Surface obs with contours. And then we're going to go ahead and open that on up. And so this is well and good. My kernel's already set since I copied it from something that I had already set the proper kernel to. And so I can go ahead and first import my needed imports here, and then grabbing that surface data and bringing it in. And I'm going to go ahead and delete this list of keys because I don't really need it there. But then I want to add in a cell because now I need to put in data access to model output or to gridded output so that we can then draw contours on our map. And so in order to do this, we need a different data access point because the thread server that we've been using for the most part this semester only keeps data for about 2 weeks, maybe a month at most. And most case studies we're going to try to do are going to be from a couple of years ago, probably, or at least even a year ago. And so there's a notebook that actually gives a couple of different ways to access different types of GFS data or NAR data or NAM data. And so we need to go ahead and copy it over. And so if we go ahead and look in our Valpo_courses, WeatherTech notebook directory, there should be one called case study archive _ gridded data. And so we're going to go ahead and copy this path because that's what we're going to want to use. Then I'm going to go back to our MET130 directory. And we see that we're in our MET130 directory here. So that's CP. We need a .. to go back a directory so that when we control V, then we get that full Valpo_courses, WeatherTech, notebooks, case study archive gridded data, and we're going to go ahead and copy that on over. And so when we do so, it should update here in just a few seconds, so then we can go ahead and give this an open here. And we've got a couple of different ways for accessing our data. And so recently, one of the main ways to access our data is to use something from NCI, the National Centers for Environmental Information, from NOAA. And that's what this GFS half degree, 1 degree, NAM 12 kilometer, and NAR data are for. Unfortunately, this server has been experiencing large issues in late 2020 and early 2021 that make them currently unreliable. Instead, what we're going to do is we're going to use some access from something called the RDA, which is an archive distribution that is kind of cultivated, if you will, by NCAR, the National Center for Atmospheric Research. So what we want to do in all of these cells is basically I've shown a way that we can access these different data sets and gain access to them. And so what we want to do then is we just want to copy and paste the elements that we need from this file. And we could have run this file to see that data access. But we'll just see it in the context here of putting it in our surface observations. And we're going to paste it in here. Now, I forgot one element here. We're using a new way of accessing this data from Siphon that we haven't yet talked about. We don't really need to worry about that. Just know that we need to bring this over and either add it to this particular cell, or we could add it up here to our input cells, which would probably be the most robust. So I'm going to go ahead and keep it all the way up at the top there and remove it from there so that then we can just have a little cleaner access. And so it's going out to the RDA to find a catalog, and we're specifying a particular file. And this data, as we see from our case study archive gridded data notebook file, we have data from 1 January 2009 through near current. Near current means, within the past maybe 2 weeks or so we have data there, and it's continually expanding. Again, for most of what we need, case studies between 2009 and the present should suffice for us. Again, here we're using the date function to set up the date variable to set up these string values that we then ultimately read in. And so we can go ahead and now run this file and gain access to that GFS data through our DS variable, where again we've subset currently for over the US. And so now what we need to do is we need to add the ability to put in contours to our plot. And so I'm going to go ahead and open up the color-filled gridded output file, because this file contained the kind of surface parameters that we needed for plotting purposes. And so the first thing I'm going to do to piece it together is go ahead and copy the contours here, which are contours for mean sea level pressure. And I'm going to add that into our cell here that does our plot. And again, we're plotting pressure reduced to mean sea level, given the plot time that we have specified up here as our date. And one thing to note is that actually we're likely going to have an error if we're going to try to plot 18 UTC data. And that is because for our gridded data, we actually need this model runtime. So I'm going to go ahead and delete that, put that up here with our date, and then just set plot time equal to the date variable. And so that means I'm going to have to rerun these cells and gain access to the 18 UTC data. Then I'm set to go here. And again, in this cell, I'm subsetting the observations by lat long to give us a little smaller subset to work with. And now I've added in this information to plot mean sea level pressure every 4 millibars and put on contour labels. Now what I need to do is I need to add this to my map. And so I need to add it to my list of plots here. So since I've added in information about plotting contours, using the data from the variable ds, which is what we've read our gridded data into, then I'm going to plot it along with my observations on the same map panel. And so let's go ahead and give that a run and see what we get. And there we go. We now have mean sea level pressures associated with our actual surface observations. The problem is I really don't like this projection, I like the projection, but my area isn't great. So I'm going to go ahead and redo my area using a bounding box. So we're going to go minus 122 to minus 68 to 20 to 55. And we'll see what that looks like. That gives me a little better view. It looks like I've gone still a little too far out east. We see where the cutoff is for our gridded data that we're bringing in. So I'll bring this in maybe to minus 72. And run it again to see what it looks like. There we go. That's looking pretty good. Now I can add in other things, right? So for example, if I wanted to bring in color-filled temperatures, we could do that. We can come back here to our color-filled gridded, and we already have something that's set up for 2-meter temperatures in Fahrenheit. So I'm going to go ahead and copy and paste that. Add in to our setting here. And then I need to add my CFill, and I'm going to do it at the beginning. Because again, when I'm color filling something, I want that for sure to be on the bottom. So we're going to do that one first. We've set it up for temperatures in Fahrenheit. And we'll see if we can get it to run. There we go. We've now created a gridded model output file with surface observations in Fahrenheit for temperature and mean sea level pressure to see what was going on that day. We see it was nice and warm on this March day across the country. Now again, we don't have a good title right now. We've just got a default title in here, and so that's something we would want to add. Panel.title. And then we could add in things like valid time. And just use our dates and say that's at UTC. But then I'm also going to put in GFS MSLP, 2-meter TMPF, and OBS. And then I'm going to do the new line character so that then I get 2 lines to my title. And there we go. GFS MSLP, 2 meter temperature and OBS, valid time, March 12th, 2012 at 18 UTC. So that's it. It's not too hard to combine a couple of these things to get the maps that we desire ultimately at the end. Again, one could play with this a little bit more. One could colorize some of the surface observations, focus in more over a particular area, maybe not go as far north or south. Again, one could still improve this a little bit. But that's how we go ahead and get some of these things together for our case study projects. And that's it for this video. Thanks for watching.